All right, any questions? Otherwise, we're going to continue on our tutorial on SQL. Last time we covered basic CRUD, create, retrieve, update, and destroy. And now we're going to do a little bit more in-depth CRUD, or at least the R of CRUD, that is the retrieve. Before we do, though, I want to give us some more records in that video game database and also show you some tricks in MySQL Workbench here. I don't know if I did it in this section, but I certainly did it in the other section last time, that you can actually insert multiple records at once. That's why we use the keyword values instead of value. Well, actually, that refers to the multiple columns, excuse me. But here's the same video game database that we were using all last week and that you are familiar with from your first assignment. And we've got all these old school platforms here. I want to insert some new platforms. So the way that I'm going to do that is I'm going to insert 3 new records at once. These are all VR systems, so platforms, so Vive, Index, and Oculus Quest. Does anybody have a Vive? Oh, Vive Pro. Okay. That doesn't anybody have a Quest? That's the most affordable. Does anybody have an Index?
Windows Mixed Reality.
Say what?
Windows Mixed Reality. That's where it's at.
Windows Mixed Reality.
It's significantly cheaper.
Okay. Whenever they replenish their supplies on indexes, I'm going to go ahead and try to get one, but not personally, but for the department. And they sold out immediately last year. So again, we've got these platforms. I want to insert all 3 of these at once, and to do that, I'm just going to provide a comma delimited list here. So here's the first record that we want to insert, the second record that we want to insert, and of course I'm putting them on different lines just for stylistically you can see them a little bit better. But of course you could put them all into the same line if you really wanted to. When I execute this, all 3 of them are going to be there at once. You see Vive, Index, and Oculus Quest all there. Okay. And was that the order? Yeah. I don't know whether or not the order is actually preserved or not, but they're all in there now. As a review from last time, remember that if we had multiple tables, we can join them together with a join query here. That I'm going to go from the publisher table over to the game table because I want to know each publisher what game did they actually publish. And when I do that, I get a record, a result table that looks somewhat like this. Rockstar Games produced GTA 1, 2, 3, and 4. Nintendo produced Zelda 2, Super Mario Brothers, and Legend of Zelda, etc. But I don't see any missing data here whatsoever. Right? So I need to remind myself, first of all, about what is the structure of our database. What is the relationship between a publisher and a game? And for that, I'm going to show you a trick here that you're probably going to want to use on the next phase and your design document. Now, you can't see it because it's on the other screen, but I'm going to go up to File, New Model, right? And that creates this new model over here. It's basically you can create a new database. But instead of creating a database, I want to reverse engineer an existing database. So what I'm going to do is in this new model, I'm going to go up to File and Import. And again, you can't see it. That's on the other screen. But reverse engineer a MySQL create script. All right. Now, what I'm going to do is I'm going to open up that that video game database that I've got here that's been pushed to GitHub, and you can test it out and try it and load it up for yourself if you want to. Before I import everything, I'm going to ask it to place imported objects onto a diagram. And what it's going to do is it's going to generate an entity relation diagram for me. You can actually create a database graphically with something like this. You can use all this stuff over here and drag and drop a new table or something. No, I don't know which one is a table, but you can drag and, oh, there. I just need to click a bunch of tables. I don't want that, so let's go ahead and remove or delete it or whatever. All right. So you can move this around. This isn't what the original looked like. Instead, what I did is I moved it around so that it looks nice, right? And there's the original ER diagram that I showed you. We can zoom in on it a little bit more. All right, there we go. And here's the relationship between the publisher and the game table. There's a 1 to many relationship. There is a publisher ID foreign key here referring back to its parent, the publisher. So if you want to, you can look at it like a parent-child relationship instead. Here's the parent. Here are the many children that it might have, right? And in the child, you always have the foreign key that refers back up to its parent, okay? So at this point, I'm going to ask the question, was there any missing data? So if I start at the publisher table and join over to the game table, will I have any missing games? Can a publisher exist without a game? Yeah. Can a game exist without a publisher? No. So am I missing some data here when I start at the publisher and go to the games? When I start at the parent and go down to all of the children? What if there's a parent without a child? Are they represented in this result? No. Instead, what I need to do is I need a different kind of join. This is technically called an inner join. This is called an outer join, and it's a left outer join. You can use those keywords if you want to. It's going to give you exactly the same thing as before. Right? This is the inner join, but again, it's so common we don't even have that name. Right? Just as aliasing your tables, you don't need to put an as every single time. It's just shorthand for, it's just shorter if you omit it. Right? So you don't have to have an inner join. Instead, you can just use a join. You don't have to have a left outer join. It's just a left join. Right? So it's a little bit shorter, more compact way of writing stuff. Now, when I do this, I'm going to get a completely different result. Not a completely different result, but there are going to be things that I did not have before. Sony, Square Enix, Sega, Blizzard, and Atari, they've not published any games according to this according to the data that I have in this table right now. The left join is what preserves those records. Okay, that's good enough. What I was doing was let me go back to my ER diagram here. Again, you are starting at the publisher table and then left joining onto the game table. You're basically joining them together. And when you do a left join, then you're preserving records in the first table with records in the second table. Now, you might be asking yourself, well, what's left about it? Well, you're just saying that starting from the left, preserve those records. So you can also ask, well, what about a right join, right? Could I start at the right? Well, you wouldn't start at the right. You could start at the publisher and then just say, preserve all of the records from the right to the left. Right? And you can do that with a right join instead. But what is that going to give me? It's really slow today. What does that look like? Does that look like the first query or the second query that we did? There's no missing data here, right? So it looks more like the regular join up here. Why is that, though? That is because of the design of the table. Again, can you have a game without a publisher? Can you have a child without a parent? No. So if I start, if I preserve, go with join the publisher to the game table, and I preserve all the records over here, then by design they're already preserved because you can't have a game record without a publisher record. Right? You could switch these around, right? And you could start at the game record and then go to the publisher record. What would that look like? Select everything from game, G, join publisher, P on P.publisher ID is equal to G.publisher ID. Right? And all this is doing is it's changing the order of the columns. Okay? If I start at the game table and then join, and then join, and then join, that is being read left to right. But this one looks like the first one, where I don't have that missing data. And that's because I'm doing a regular old join. If I did a right join, what would that look like now? Now that looks like the second one, where I'm starting at the publisher or the game table. Sorry, the game table. I'm preserving things on the right to the left. And that's the right join. Preserving things from the left to the right. That's a left join. So that's where the left and the right comes in. Preserve records starting from which direction? The left direction or the right direction? Okay. All right, you can also use them in combination. How might we use them in combination? Let me go ahead and let's see. Let me give us a task here to do something. So flatten the game platform data model, right? That is, I want to report all games and all platforms that they are available on. Right? So here's my first attempt at a solution for this. In the data model here, and now publisher, I don't care about that anymore. We'll put that over here. I want to join these three tables together. I want something that looks like this. Game over to the availability table and then over to the platform table. And this is where we kind of left off last time. Select, star from game G, join availability A on g.gameID. And remember, you go through foreign keys, because if you don't go through the foreign keys, then you get weird results. Joining a publisher's name to a game name, that doesn't make any sense. There's no there's no game named Nintendo. There's no publisher named Zelda, right? Or Mario or whatever, right? So the game ID in the game table is equal to the game ID in the availability table. Now I need to join one more. If I'm going to join from the game to the availability, I also need to join over to the platform. So join platform P on a.platform ID is equal to p.platform ID. Right? Execute that, and I get a list of games, right? And the platforms that they're available on. Obviously, I'm going to get duplicates here because Lego Star Wars is available on Xbox, PlayStation 2, PC, and Mac. Right? And I'm also going to get 2 GTAs here because they're available on PC and Xbox 360. But I seem to remember that there were, well, in fact, there were more than 4 GTAs now. What about GTA 1, GTA 2, GTA 3? Right? The GTA 1 was not actually GTA 1. What was it before? It was called GTA, but it was like an above platformer. Has anybody ever played the original GTA? Where you had a top-down view?
GTA London?
Let's say what?
London?
London? That was actually the second of the two. The top-down view. I don't even remember what the first title was called. But anyway, we're missing those. Why are we missing them? They're definitely in the database. What kind of a join am I doing over here, though? A regular old join. So I need to do a left join. Is that going to be sufficient here? Are you getting GTA 1, 2, and 3 now? Nope, not yet. Why? If I join from the left join from the game to the availability table, that preserves all the records that in the game table that have no availability records. But then if I do a regular join over to the platform table, I'm losing those records on the second join right here. So if I want to preserve all the records all the way through, what do I need to do? A left join, left join. Oops. There we go. And now I'm getting GTA 1, 2, and 3. And they're not available on any platforms here. Okay. All right. GTA 4 was, no, 3 was San Andreas. Okay, 4 was what? Liberty City. Okay, back to Liberty. Then 5 was Massive Online version, right? All right, nobody played. I thought you all played video games. But apparently not. Just play other video games apparently. All right. So, what about those 3 platforms that I just inserted into this database? Let me run this query again, and do you see Vive, Index, or Oculus over here at all? No. Why? Because if I stay over here and I preserve from the left to the left to the left, from the left to the right using a left join, am I going to get any platform records that have no games on them? No. So, let's go ahead and fix that. I'll do the same query, same order. Again, the order just means that the game columns are here, then the availability columns, then the platform columns. You can switch those around all you want. In fact, you can select a subset of those if you really want to. What I really want, though, is a right join, because I want to preserve records in the platform table all the way over to the game table, right? I'm going to have the same order here, but preserve records from platform to the availability to the game table. When I do that, I do get Vive, there's index, right? No game records, right? And Vive, no game records, and where's Oculus? Right there. Oculus Quest, no game records. But same problem as before. Let me run that again and sort the games. Do you see GTA 1, 2, and 3 here? Nope. Because again, if you're going in the opposite direction, you're going to lose all the games that have no platform. My ultimate goal here is to preserve all of them. Right? So what I want to do is I want to combine these two queries together. Now, if you look at this from a set point of view, this is a set. This results in, we actually call these result sets. So here's a result set. Here's a result set. If I've got two sets and I want everything in both of them, how do I combine them? What set operation do I do? Union. And when I do that, I get GTA 1, 2, 3, no game records. And over here I get, where's index? Probably at the end. Vive, index, and Oculus, no game records. Or no platform records for GTA 1, 2, and 3. The union here is combining them together. Right? And by the way, there aren't going to be any duplicates here, but if there are duplicates, right, in general, if you've got a set is a collection of unordered unique elements, A, B, C. You're not going to have multiplicity. You're not going to have A, B, B, C, right? You're only going to have A, B, C. Likewise here, you're not going to have any duplicates. If you want to preserve duplicates, you can go union all. But you're not going to have any duplicates here because of the design of the database anyway. Okay? All right. I guess you could have duplicates technically if you put in two availability records that were exactly the same. The GTA 1 is available on PC, released in 2000 whatever. And then again, if GTA 1 is available on PC, released in the same year, you could have duplicate records there. Or you could go back to the drawing board and make sure that you don't have duplicate records by putting on a uniqueness constraint, which we'll do by the end of the day. All right, that's how you can combine things together. And by the way, I went in the same order here because if I didn't, then the first set would be game data, availability data, and platform data. If I went in the opposite direction here, platform data, availability data, game data, then there would be the complete mismatch. And the data would not be comparable in these two sets. All right? Okay. All right. Questions so far? No? All right. Those are basic joins: left join, right join. Same thing. Otherwise, you can reverse it, and then also union if you really need to. Modifiers. So you can modify the results that come out of your database. Like, for example, what we did here is we unioned them together. We took these two sets and added them together. If you want to ensure that you only have unique values, you can do that. To select only distinct unique values in a database, use the distinct. Let me put offset distinct keyword. So, for example, select publish year from availability. When I do that, I get duplicates. 1980. Well, let's see. I get two 1989s. I got two 1992s, several 2007s, several 2011s, etc. What if I only wanted the unique values of that column? I can place a distinct in front of it. And when I do that, I'm not going to get, sorry, I need to sort it. There we go. There's only one record for 2011 now. So it gets rid of duplicates using distinct. Right? You can also use an in clause. You can also use an in clause, to define sets. Right? So for example, let me go ahead and pull this so I don't have to retype it all. I want all of the records corresponding in the availability table to where publisher year is 1988, or it's 2005, or it's 1992. When I execute this, I get all of the records that are either one of those three. Right? Now, if you're doing this in a very large, these are called disjunctions, ORs. You've probably done logic already in 235, right? These are called disjunctions. What are ands called? Conjunctions, right? Or, there we go. Technically in grammar, they're all called conjunctions, right? But we need something different in logic. So ORs are all disjunctions. I can shorten this up a little bit if I've got select star from availability where publish year is in 1988, 2005, 1992. Right? And I get the same results. But it's a little bit more compact. And in fact, with a disjunction, you have to actually hard code all of those things. With an in clause, you can actually create a subset here using a nested query. So for example, if I want to select everything from game, left join, availability, there we go, game G, on G dot game ID is equal to A dot game ID, where publish year in, and then I can make another query here. Select everything from game where name, like, and then it starts with a G. Right? And this is a sub-nested query. This will result in a result set of a bunch of stuff. Now, what I want, not publish here, sorry. Game ID is in, and then I need to select game ID. There we go. Oops, from game. There we go. Are you good now? There. Still not good. Game I misspelled game ID somewhere. From game where name like. I have to disambiguate it here. There are two game IDs here. There's a G.GameID and a A.GameID. I'll go ahead and go with either or. It doesn't matter because I'm joining on them and they're equal. And when I run this, now I'm only going to get those two GTA4 records. Because GTA4, let's see, starts with G. Because it's a regular old join. It's not a left join. Let me go ahead and change it so that it is a left join. Oh, no, it's a left join. Why are you not? A.GameID, but they're all null in the availability table. So if I go with G.GameID, then I'm going to get all those records, right? You can see over here the availability of the game ID over here was not null in this column right here, but the game ID is null for these three records right here, right? And that's why I was screwing up. Okay, but this allows you to create another query that creates a set, and then you can use an in. Otherwise, if you wanted to dynamically do this and pull out 3, 4, 5 values, you would then have to go and hard code all those values with a big disjunction. This, or this, or this, or this. But an in clause allows you to do that with a nested query. Another modifier is the order. Okay, so in general, results are unordered because they are a set, right? So sets are unordered. To impose an ordering, in other words, to sort them, you can use the order by clause. So, for example, select everything from, you know what? Let me go ahead and grab this and modify it so that I don't care about the where clause anymore. Let's just go ahead and select all the games on their availabilities and order by. And then let's go all the way to the platform table. Left join platform p on a.platform ID is equal to p.platform ID. And I don't want too much data, so let's go ahead and get rid of some of this data. I'm only interested in the game name, the publish year, and the platform name. Right? So let's go ahead and change these and only select those three columns with some aliases. So g.name as title. Let's see, a.publish year. And we don't have to give that one an alias. And then finally, p.name as platform name from game G. There we go. Now this is much more manageable data here. In the IDE, I can always go ahead and resort this all I want, or I can go over here and resort it like this. Right? what I can do that's my IDE. That's my MySQL workbench doing that work for me. If I want to do that directly as it comes out of the database, I can order by title, right? Because I aliased it to the title. Right? And now you can see that Contra is first and Zelda is last. So what's the default ordering? Lexicographic and in descending order. What if you want, sorry, ascending order, right? If you want to be explicit about it, ASC is short for ascending. Same order here, that's the default. If you want the opposite, what do you think you do? Yes, descending. Right? And now Zelda is first and Contra is last. Okay. You can also do by multiple columns. So let's go ahead and order by publisher or platform name. Let's say platform name ascending, and then title descending. So what this will do is all the NES games will be chunked together because we're going to order by them first, and then we'll order by the title in descending order within each one of those groups. So I see right here NES, 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 those are all together, and then Zelda comes first, and Legend of Zelda comes last, L. All the PC games are here, but it's X-Wing first, and then GTA last. So you can order by pretty much anything that you want. Ascending, descending, numerical values are of course allowed. And tell me about null values. If I'm sorting by platform name first, where do they come? They come before everything else, right? So that sounds kind of familiar. Think about C. Where does the null terminating character come from, or come in the ASCII text table? The very first one. It has a value of 0. Right? Okay. So, yeah, go ahead.
Could you, instead of like sorting according to the alphabet, which is essentially an arbitrary sequence of characters, could you sort according to a different arbitrary sequence of values?
Like what? I mean, if it's numbers, like what publish year,
like,
then.
Like G, V, Z, like could you make a.
I've actually done this as a programming exercise before for this course, where I gave you a custom dictionary, like an alien dictionary. Now you have to sort all these alien strings according to the alien dictionary. And in SQL, I don't know. You probably have to define like a temp table. You could probably do it with like a temp table where you put in your arbitrary ordering in that table, and then you sort it according to that. You can write loops in SQL. You can write like traditional code-wise in SQL. So you could do it somehow. It's just I don't think I'd want to do that. I'd use a different tool to solve that problem.
Instead of fields like platform name and title, could you put another select clause in there? Like in parentheses?
Order by, because the ordering has to be part of the actual result table. It's got to be one of these things. Otherwise, if you're, I see where you're going. Maybe like if I randomly create a value, you can do that. Random as foo. I don't know. I don't rand. No. Okay, there we go. There. And now I can order by that random value that's going to change every single time that I do this. Order by foo. There. And now it's random. Now it's randomly shuffled, right? This is a way to randomize your results if you really want to do something like that. Here, I got rid of it. Let's make sure that it's actually working. Legend of Zelda category. There, it's random every single time. But that's only because I'm calling this random number generator provided by SQL. So yeah, you can do something like that. Right. All right. Let's see what else. It's the order by clause. All right, and then aggregates. And by the way, there are lots of other modifiers and stuff like that. There are way too many to go over. I'm going over the most useful stuff, the most basic stuff. There are dozens upon dozens upon dozens of functions that you can use and usefully. Some of them are not interoperable. In other words, some of them may work on MySQL and not work on Postgres. Postgres might have the same feature, but using different keywords. You're going to have different dialects of SQL depending on the vendor, depending on the database that you're actually going to use. SQL Server uses Transact SQL. MySQL uses, what do they call their dialect? I think it's called MySQL, but I'm not sure. People come up with different dialects and call them different things. But there are aggregates. For example, the count aggregate function allows you to count the number of records. So for example, select count of everything from game. How many games do I actually have in my database here? We might have done this before. 21. Now, you'll note here that this is not a real column. It's the aggregates function's name, count star. If you need to give this an alias because you want to pull it out of the database and actually have a name for it, well, you can use an alias here, number of games. And you can see that it's labeled up here. This is especially going to be useful when you programmatically access your database and execute queries and pull them out. You're going to have to refer to the actual values, and you need a name to do that. Originally, there was no name for this. Okay? I can select the minimum value among a bunch of things. So name from game. Right? If I ordered them lexicographically by name, then I can do the same thing and find a contra as the minimum. What do you think? What was the maximum? Do you remember? Zelda. Right? There we go. Zelda 2. Right? And of course, I can do that with lexicographic strings. I can do that with numbers. So publish year from availability. And I can get the newest game, which was published in 2011. The oldest game, of course, would be, I think it was published in 1985, right? Yeah, Mario Brothers or whatever. All right, here's another good shibboleth. I think it's a good shibboleth for how old you are. Mario Brothers or Mario Brothers? Mario? Mario, okay, good. Mario, that tells me that you're at least like 60 years old or something like that. Maybe even older. So, Mario Brothers, exactly. Well, if you could do the min and the max, what else might you want to do? Oh, mode. Mode. Mod is going to be, ooh. Nope.
The most common published year?
Yeah. Well, yeah, you could do that. 2011, there were 5 games published in that year or something like that. Something like that. So there could be multiple modes or one other mode. You could also do average. Right? And the average of all published years, whether or not that's useful information, I don't know. But the average is 2,000. And you could do stuff like basic math. So what's the minimum plus the maximum? You can embed operators directly in your SQL queries. So that was 1985 plus 2011, which is 3,996. What if I wanted to multiply them together instead? Well, that makes even less sense, but you can still do it. You can also divide, and it will do floating point arithmetic. That's, what was that? 1985 divided by 2011, so it's 0.9 something. Of course, you can go ahead and try to truncate that. Take a floor. 0. You can take a ceiling. 1. You can even round. So lots of different math functions are available, aggregate functions for you to operate on. Okay. All right. Questions so far? No? So then let's go back to homework 1. What was one report that you had to generate with homework 1? You remember?
How many platforms each game was on?
How many platforms each game was on? What was the other report? How many games each publisher created, right? So let's reproduce that report, but let's do it in SQL instead. For each publisher, report how many games did they publish. So let's go ahead and try with a regular old select query here. From publisher P join game G on P dot publisher ID equals G dot publisher ID. All right, that's my first start here. But you remember that we're missing something, right? What are we missing? Remember any of the publishers that didn't have any games? I think Atari maybe is one of them, right? So I need to do a left join and I'll get those in there. But that's not what I want. What I want is an aggregate report. I want LucasArts, or let's say Atari, 0. I want Capcom, 2, because they've got Contra and Mega Man 3. I want Delphine Software, 1. They've only produced one game. I think that they only did one game, too, which was an awesome game. Has anybody ever heard of or played Out of This World? No? Old school, early 90s vector graphics? No? All right, highly recommended. All right, anyway. I don't know what my shibboleth is going to be and how old, you can tell how old I am or something. But anyway, what I want is this report here. So I want those numbers. I just want the publisher name along with account. Right? So this is going to require me to show you a little bit graphically here. Let me go back to lectures. Sorry, I should have had this up and running. There we go. And here we go. All right. I'm just going to use these slides because I've already got a nice graphical way of representing this. And you know what? I spent so much time on it. I should pull out this this graphic here. Where is it? I spent so much time creating this graphic last summer. It's not that big of a deal, but spend so much time on it, you might as well show it off. Where is it? It's in the book. So if you, there we go. So what is that thing? Well, ignore the caption. What is that thing? It's a box, right? So it's a projection, right? A three-dimensional cube being projected down onto two-dimensional space. Now, why would you want? You see all this all the time, where you are, if you've got 3 dimensions and you're projecting it down onto 2 dimensions, what are you doing? You're taking away one of those dimensions. You're crushing those dimensions. You can even do this with higher order dimensions. A 4-dimensional cube, when you project that down onto, we can't see that, we can't imagine that because we're 3-dimensional beings. But when you project it down onto 3 dimensions, what do you get? Hypercube, otherwise another name? Tesseract, exactly, from Avengers or whatever it is, right? You've got the Tesseract, where it's a cube within a cube and all the corners are connected. You can also have 5-dimensional cubes, which are 2 Tesseracts connected together at their endpoints. And then, of course, you can go up and further dimensions. You can go up and down dimensions all over the place. If you want some book recommendations, my first book recommendation is going to be Flatland, which is from the 19th century. It's about, anybody ever heard of it? All right, it's a kind of a comedy. It's a thought experiment on what would happen if a 3-dimensional being encroaches on a 2-dimensional world, right? They do that. It's called Flatland. It's because think about that in higher dimensions. What if we had a 4-dimensional being encroaching on our 3-dimensional world? Well, just like a 2-dimensional world, if a cube, 3 dimensions, encroaches on a 2-dimensional world, then you only see a slice of it. You only see a square. Right? So from the perspective of the 2D world, it would look like magic because you could go inside of something, pull something out the center of a square, and then put it somewhere else because you can go into the 3rd dimension. 4th dimension, what's possible? You can take things out of time and move them around, right? And then you've got the other movie. What is it? Interstellar, I think. Okay, yeah. The idea in that one. This is old stuff, by the way. This is Flatland was from, I believe, the 19th century. Otherwise, more recently, my other book recommendation is going to be the 3-Body Problem, which is a trilogy by a Chinese author, and they use dimensional weapons. So They fire this dimensional weapon at Earth's solar system that basically crushes the solar system. Oh, spoiler, sorry. It crushes the solar system into 2 dimensions and destroys it. Right? So very, very cool stuff. Very, very cool science fiction books, and I'll recommend that. Why is that important for data? Right? So, title, author, number of copies. Consider this just single table, simple single table here. What I want is a report. I want a report on how many copies of all the books by Norman Mailer do we have in our collection. In other words, this book plus this book, 13 copies of Norman Mailer books. Douglas Adams, we have 4 copies of Dirk Gently. We've got 2 copies of Hitchhiker's Guide and 1 copy of Long Dark Tea Time of the Soul. So we would 4 plus 2 plus 1, 7. We only have 1 Orson Scott Card book, but we do want to know how many copies we have, so we would sum up 7 right here. And you can imagine that if we had an author with no titles and no number of copies, we would also want to include them in that report and report 0. Just like publisher that has not published a game, we should report that as a 0 as well. So how does projection help us here? What I want to do is I want to take away 1 dimension. The dimension I want to take away is title. To do that, I want to sort, order, or group all of the authors together. Once I've got all the authors together, I can project down using an aggregate, the number of copies, 10 plus 3, by getting rid of this dimension over here. And Norman Mailer, when I crush that down from 3 dimensions into 2 dimensions, like our solar system and 3-body problem, it's okay because Norman Mailer is Norman Mailer and it's preserved. When I crush down these 2 dimensions, it's going to be 10 plus 3, giving me a new number in that new dimension. And it should result in something that looks like this. Right? That's the projection of data down by getting rid of 1 or more dimensions and then aggregating them somehow. When you crush it down, how does it get crushed down? Okay? So, what does that look like from the perspective of SQL? Well, here's the query that did that. I'm going to select the author, and then I'm going to use a sum aggregate. We already saw a min, max, average. You can also take a sum as a total number of copies from book grouped by the author. If I had grouped by the title, then that wouldn't have made sense. I would have been crushing the wrong dimensions. But by grouping it by the author, I'm getting what I just described here. Group it by the author, crush it down into 1 fewer dimension, and sum up that other dimension over here. What does that look like with respect to a publisher? Right? I want to group by what? Let's take a look at the results and figure out what we want to group by. I want to crush this dimension right here, LucasArts. I want to group by the publisher name. Group by p.name. Now, I'm not going to select all that stuff anymore. I'm going to select p.name as publisher name. And then the other thing that I want is, I'm not going to take a sum. I want the number of records. So LucasArts, there were 3 records. How do I count the number of records again? Count. And for now, I'll just count everything. There we go. Now, do you remember? Let me go ahead and sort it by this. Okay, I can't. I don't know why. Do you remember Nintendo? How many did they have? 6. Okay. Do you remember how many Atari had? Was it 1? No, it was 0. Why am I getting a 1 here? Let's go all the way back to what we had before. I shouldn't have deleted it. Select everything from publisher P, left join. Oops. There we go. So, where is Atari? There we go. Atari, how many records do you see? 1 record, right? Even though these 3 things are missing, it still counts as a record. So I shouldn't be counting the number of records. I should be counting what? The game ID. And then if it's, I'm not summing those up, so it's not like 8 plus 19 gives me 27. I'm just counting the number of records that there's no null value here. Null gets counted as 0. So if you sum up a bunch of nulls, null plus null plus null, or count null plus null, 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 there's actually nothing there. So I will change what I'm counting. Don't count everything, only count, g.game ID. There. And now Atari, 0. In fact, if I sort this, there are those 5 publishers, 1, 2, 3, 4, 5, without any games, and I get 0. If I wanted to sort them, because that was we had you sort by the publisher name, right? Okay. So order by publisher name. There, and I just reproduced your assignment 2 or assignment 1 using SQL instead. Okay. Another thing here that I would clean up is don't group it by the name, because if you had 2 publishers with the same name, they would get collapsed together. Instead, what uniquely identifies a publisher? Publisher ID. That's better. Right? You'll get the same result here because I don't have 2 Blizzards. I don't have 2 Delphines. Right? All right. Well, here, let me show that report one more time. What if I only wanted ones with at most 5 games published? In other words, I wanted to exclude Nintendo here. Okay? I might try to do something like this, where, and I need to give this a name now, as num games. There we go, where num games is less than or equal to 5. Okay? It's not even going to let me do this. It's because the where is basically a filter. I want to select data out, filter it out, and then project it. I can't filter it afterwards. So I want a way to filter it afterwards. So what I'm going to do is I'm going to have another keyword here, having num game is greater or less than or equal to 5. Having is for not how being not cutting it in half, but having is a way to filter the data after projection. Right? And when I do this, Nintendo is no longer here. Right? And of course, I could cut it out on the other end too. You can put in whatever other conditions you want, and num games is greater than 2. Right? And then that cuts out most of them. Right? But that, if you're going to filter after the projection, you have to have having. You can filter before the projection too, where, I don't know, p.name like, or is greater than or equal to, what's the middle letter? M? There we go. And now I'm only going to get Rockstar Games. What was the other one before, without that have where? There, LucasArts. I'm excluding LucasArts. And so, oops, sorry. There we go. Where name greater than M. There we go. So where clauses happen before projection, they filter, then you can project, then you can filter again. And of course, ordering it only makes sense at the very end once you're done manipulating the data and changing the data. You can't order by p.name up here. Right? That doesn't make any sense because ordering is the last thing you do. But there is a nice query that basically illustrates all the aspects that we've covered up to this point of SQL. You've got select for retrieve, the R CRUD. You've got aliases. You've got an aggregate. You've got a left join to preserve records even if they haven't had any published games. You've got a filter prior to that using a string comparison. You have a projection so that you can take an aggregate of something. You've got a filter afterwards, and then you've got a way that you can sort stuff after it's all said and done. So that's a nice little query that illustrates everything that we've covered up to this point in one query. Right? And you can get way fancier than that. That's just a simple one. Questions so far? No? All right. Then let's switch modes a little bit. I'm going to make sure that you've got this in your notes. It's also in the main section's notes if you want them. SQL. There we go. Those will be pushed out later today. But of course, I started with existing tables, right? Because I wanted to do basic CRUD to understand the data, to understand data relationships between each other before we actually define this stuff. Now what we're going to do is we're going to create our own tables. So to create a table, what do you think? What keywords do you think you use if you want to create a table? Create table. You need to give it a name. So what are we going to do? Let's model films and directors eventually. Let's go ahead and take care of films first. Is films a good table name? Oops, sorry. Is it the films table or is it the film table? Which one sounds better in English? Film, okay. It contains film records, S, but you generally don't want to pluralize things. Just like you don't pluralize your classes. If you were to create a Java class, would you call it the film class or the films class? Probably the film class. It represents a film. You can have multiple instances of that class to represent several films. And of course, the table will have several rows, several records representing several different films. So create table film. Right? Now it's complaining here because I haven't actually put anything into this table. So tell me, what defines a film? A what? Title, okay. Now what type should that be? Is that a number? Is that a string? What is it? String. And in SQL, a string is a varchar, a variable character array. It's not even really an array. It's an array. Sure. Varchar, or variable character. I put 255 in here. You'll see that all over the place. I think it's legacy, that it only takes 1 byte to address it. It's one less than 156, meaning that 156 character might be a null terminating character of some sort, like coming from C. There's really no reason to do that. You can have other aliases like small text. Right? Let's see. Tiny text. There we go. You can have text. You can have big text? No. What is it? Long text. There we go. Long text. Right? Long text, it depends on the database that you're using, but they have limits. For example, long text might be like up to 4 gigabytes or something like that. If you want to store an entire novel in your table, go ahead. But probably may not want to do that. I don't know. Right? It really depends on what you're doing. But varchar 255, that's certainly large enough for any reasonably titled film. Right? You could have a film, what's the Birds of Prey one? It came out and flopped. Oh, okay, that's why it flopped. Nobody knows what I'm talking about. The Harley Quinn movie, that was what they should have called it. I didn't see it. What is it? It's a super long title, though, right? Fantabulous, blah, 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 yeah. So maybe that would be too long for this, but so be it, right? So should we consider this data optional or not? In other words, should you allow a user to put in a film record without a title? No? All right, I agree. So we'll make it not null. The default is to allow something to be nullable. If something is nullable, then they don't have to provide a value for it, or they could update it to null and erase the title or something like that. But the title here, not null, means that nobody will ever be able to insert data without a title. Now, they could insert an empty string. They could insert title to be named later, right? They could insert whatever data that they wanted, but at least we have a guarantee that there is data, that it's not just simply missing. All right, what else is a film? Okay, director. I'll put a question mark here. What is that? How would you represent a director? Oh, so you're thinking object-oriented programming here. That sounds like it's a different thing, like an entity. So you might have like a director class or a person class, and then you would call that instance a director, and then it would be a person with a first name, last name, middle name, date of birth, whatever else you wanted, right? So I like that, but in the context of SQL, what is it going to require? Another table. So I'll put a comment here, to do. That's not a proper comment. This is a proper comment. To do, model a director. Later, right? Okay. What else? Thinking about a film by itself. Say what? Okay, a release date. And what is that? It's like a year, day, month. There is a date type, as you can see by that blue. Don't use it, never use it. It's not interoperable. They're terrible. It's not localizable. There's just way too many problems. What I'm going to do is I'm going to use a varchar here. 50. I will use a string representation. For example, 2020, today is the 25th. There we go. Something that looks like that. I'll ask the same question here, though, about this varchar. Is it essential data? Maybe, maybe not. Not all films are released on the same day worldwide, right? So maybe we have different days. So maybe you could argue that's not essential data. So instead of putting not null, I'll go ahead and say, well, you can go ahead and forget about that. It's not essential that you have that data. You can explicitly say that it can be nullable, null, or you can just leave it alone because that's the default. Right? If you do want a default, though, you can put one in. So let's put it in a placeholder value here. A placeholder value that this indicates that when somebody entered this data, that they did not provide a date. So we're going to provide a flag value for the date instead. Using the default keyword here and providing a default value right after allows you to do that. Okay? What else?
Film ID for the primary.
Ah, good. There is no way to identify this film. In real life, do you know how films or media is identified? Think about a book. How is a book identified? ISBN. How is a person identified? In the United States, Social Security number. Right? How is a student at UNL identified? NUID. Right? These are called natural keys. These are unique identifiers that another authority has created and assigned to them. Right? We're going to use what's called a surrogate key instead. Film ID. Right? So naming convention here, same as the tables are general. I'm following a modern naming convention, by the way. You can follow another alternate naming convention if you want to, as long as you're consistent about it. The modern naming convention is kind of matching Java. So the table and the class, those are kind of the same thing. So I'm using upper camel casing. Member variables and column values, those are kind of the same. So I am using lower camel casing. The old school way of doing this would be film _ ID. What's the problem with that, though? If I'm typing this over and over and over again, what am I doing? It's my poor little pinky finger. Holding down the shift key, going all the way across the keyboard to hit that hyphen, right? And so eventually my pinky is going to fall off, and I don't want that. So I'm going to use the more modern convention of lower camel casing here. Right? As long as you're consistent about it, it doesn't matter. Right? So film ID, what type should it be? Should it be a string? Should it be, I only have a couple of choices here. An int, integer. Both of those are the same, by the way, int, integer, right? Aliases of each other. I'm going to make it into an integer. Why might I not want it to be a string? String foo versus string foo. If I'm going to match these up together and say that this one is equal to this one, what am I doing? I'm doing lexicographic ordering, meaning that I'm going to have to look at every single character, and if it's 50 characters long, that means 50 checks. Right? Whereas it's just one number that the processor can take care of that immediately if it's an integer. Not only that, but then I have to worry about case sensitivity. Foo, capital foo, are they the same thing? I don't know, because I don't know if it's case sensitive or not, the way that I'm doing this, right? It depends on how you created the table, depends on how you created the column, it depends on how you are creating the query, it depends on a lot of things. Let's make sure that we're not depending on that stuff. Too many question marks. Integer, there's no question mark there at all. An integer is an integer is an integer. I want this to be a primary key. So I use the keywords primary key. The primary key means that every film in this table will have a unique film ID. Right? I'm going to let the database do its job and take care of the key management for me by letting it auto increment this key. Meaning that if every time I insert a new record, it's going to take an unused key and use it for me. You can always go ahead and try to insert it with a particular primary key value. Insert film, was the last thing I saw. I haven't watched any movies in a long time. Give me something. 1970. 1917, the film, 1917, and 101 for its ID. As long as 101 is not taken, then that's going to work. But if there's already a film in there with ID 101, then it's going to fail. Let the database do its job. Let it auto increment for you. Now, the same question I asked about the title and the release date. Should we allow this to be null? Probably not. We could, but then there's going to be one record in there that has a null key value, and that's not that much of a use. Okay. Okay. Primary key, not null. Oops, I need to put that after primary key. Not primary, not null key. But primary key, not null, auto increment. Okay. Like I said, this is called a surrogate key. It's a key that's for our database, generated by our database, and is going to be used in our database. We may want an external ID, like for films, I believe that, according to my notes here, it's an EIDR. Do not ask me what that stands for. We'll have to look it up instead. EIDR, look up. Entertainment Identifier Registry. Right? You. All right. So let's see. Where's the search? Search. You said 1917? And let's search for that. What's that identifier? Oh, there's several. There we go. Title is edit of. So it looks like there's several things that have been published under that. So there was a 1917 short film released in 1970 with the same name. But otherwise, this is the one that we're probably thinking about, the one that was released a few months ago. And there's its ID. What does that look like to you? Looks like a Library of Congress kind of thing. It's definitely alphanumeric. So maybe we want to incorporate that over here. It's going to be a bar chart. I don't know. 100 is big enough. But this is a natural key that is generated by this group over here. Now, I won't pick on them. Instead, I'll pick on UNL. How do we identify students at UNL again? NUID. Do you think in the history of UNL, no two people have ever been issued the same NUID by mistake? Probably not. I'm sure that that's happened. Do you think in the history of UNL, one person hasn't been erroneously issued two NUIDs? That definitely has happened. I've seen that. Right? So those are natural keys. We don't want the incompetence or the mistakes of others to basically screw up our own database. If they ever screwed up and created two ISBNs or two EIDRs that were the same, or maybe this is actually a fix, like it says this is an edit of something else, maybe they screwed up or they superseded it or something like that, and we don't want our database to be screwed up by other people's mistakes. So what I'm going to do is I'm going to create a surrogate key that I know my database will always get right, as long as SQL is right. If SQL screws up or there's a bug in the database, then so be it, but at least it's my problem to deal with and not somebody else's problem to deal with. Because if two students are issued two NUIDs and we use that as our primary key, that means that it's screwed up all of our data throughout the database. Whereas if it's just one column value in one table, then we can go ahead and change that and make a fix and be done with it. Right? But there's still a problem here to do. Make sure that the EIDR is unique. Right? And yeah, we have enough time. I think it's just going to, here it is, unique key. That's it. There are two things going on here, though. First of all, it's a key, and we'll talk more about that next time. What does it actually mean to be a key? It means that some order is maintained so that fast lookup can occur. Hopefully you remember last semester. What's an efficient way to search? There are two ways that we could search. You remember we covered? Yeah.
There's linear and binary.
Linear and binary. Linear search is of course linear. If you've got 1 million elements, you can take up to 1 million comparisons to get there. Binary search though, you go in the middle and you cut that down, you go one way or the other, and you basically have logarithmic performance, exponentially faster. But binary search required what? Sorting. It required it to be in order. So that when you jump to the middle, you knew that everything over here was greater, everything over here was lesser. If you put a key on it, then that means that the database can maintain that order, and it can exploit something like binary search. Of course, it's stored in trees instead, and it's not strictly binary search, but it's the same basic idea. So if you don't have a key on it, that means that it potentially has to go with linear search, which really will slow the database down. The unique thing over here is a constraint. That if you ever try to insert two EIDRs of the same value, 1, 2, 3, and 1, 2, 3, it'll reject the second one. So that's a way that we can maintain natural keys in our database without being dependent on those natural keys, and instead using our surrogate keys up here. This is a really good start to our table. But I want to put in two more things here just for variety. Yeah?
Are primary keys already unique?
Yes, because they're a key. So here's another thing that I would suggest. Here's primary key, primary key. Does that make any sense? Can you have two winners? No. Anybody watch basketball here? I don't watch basketball, but the recent controversy with the dunk contest, there should have been two winners or something. Oh, no? Okay. They didn't know anything about that in the other section either. Okay. Anyway. Come on. I'm missing the fourth spring training game right now for this class. The first 3 innings are always the best because those are the starters, and then it just gets into AAA rosters. Anyway, unique key. You can't have two primary keys, but you can have as many other non-primary keys as you want. I could put a key on the title and a uniqueness on that so that I can never have any two movies with the same name. But as we've already seen, clearly you can name your movie 1917, your student film 1917, and you won't get in any trouble, right? So maybe we don't want to do that with the title. Certainly don't want to do that on the release date because that means that only one movie can ever be released on each day, and we know that that's not true. But I do want to put in some other things here. For example, gross earnings. Is that an integer? I mean, if you don't care about cents, sure. Right. It earned $1 million and no cents. So another way that we could do, another example would be maybe an IMDb rating, Internet Movie Database rating. So what scale is that on? Do you know? 0. Well, not 0. Hope you can't rate a movie 0. Okay, 0 to 10, hopefully. But then it's fractional, right? It takes an aggregate, and so you can have a movie rating of 7.5 or something. So for that, we would need a floating point number, and we can use double. We can use float, which is much less accurate double. We can use decimal and say that I want 13 digits of accuracy with 2 decimals of precision. We can use float with 13 digits of precision and 2 decimals of accuracy. Or we could just make it a double. Right? There. But there are lots of aliases. There are lots of different ways of representing numbers and enforcing constraints like this. Right. Let's actually go ahead and run this and see what, and it's completely fine. Green means go. Green is fine. If I show tables, I can see that now I've got that other table here. Film has nothing to do with a bunch of video games though, right? You will only have access to one database, your database named after your login. That doesn't mean that you can't have multiple tables that are unrelated to each other living nicely side by side. I'm doing it right here. So when you do your albums database tomorrow in lab, that stuff can live alongside your project tables as well, as long as you don't have something named albums or album in your project, right? You can't have two tables with the same name, okay? I immediately need to make a change. I do want that gross earnings now, right? Gross earnings double. I'll go ahead and try to recreate it. Can I? No, because like I just said, what? The table film already exists. So how do I get rid of a table? I drop it. Drop table film. Run that. Rerun this. There we go. And now it's restored. Show tables. There it is. When it actually executes, there we go. You might find yourself doing this over and over and over again. So there are modifiers that you can put on there. Drop table film. If I drop it twice, obviously I'm not going to be able to do that. It doesn't exist. So drop table if it exists. And now I can do this as many times as I want. It'll only be a warning now, right? Because now it doesn't exist. Now it doesn't exist. You can do the same thing with create table. Create table, but only if not exists. There. If not exists. Now you can do this as many times as you want. And of course, it's just going to be warnings now. It's super slow for some reason. So you can add on those modifiers so that you don't have to worry about, does the table already exist? All right, then drop it, then recreate it. Drop it, recreate it. Yeah?
For like the IMDb rating, could you put it so the person could only put in a number from 0 to 10?
Yes, you could. You just stumped the chump. Constraint foo IMDb rating greater than 0 or greater than or equal to 0 and IMDb rating at most 10. Constraint foo, nope. Maybe up. Are you happy now? No. Constraint. Constraint. What is it? You name the constraint, and then something else goes here. What is it? SQL constraint value. So check constraint. There we go. Check. Check constraint. You have check. I spelled it right? Fine. What? Check. All right. I don't need a constraint. I do, and in fact, I don't even need to name it. Check. There we go. Now, I will go ahead and recreate this, but of course, so drop it, recreate it, and it's happy with this, and that's how I can put in it's called a check constraint. If you ever try to insert a record with an IMDb rating that is outside those bounds, it should reject it. MariaDB does not reject it because MySQL does not reject it. MySQL does not support check constraints because Oracle doesn't want you using MySQL. They want you paying for their actual database. MariaDB is free. It's a drop-in clone of MySQL, but they don't support check constraints because MySQL doesn't support check constraints, and they need to be 100% compatible, bugs included, bugs and lack of features included. If you were to use Postgres, yeah, this would be enforced. If you were to use SQL Server, if you were to use Oracle DB, then those check constraints will be there. Yeah, you can go ahead and define them, and I encourage you to explore that and do it for your project, but the MariaDB instance over on CSE will not enforce them. Right? It'll accept them, but it won't enforce them. Good question. All right, next time.